Okay, so good afternoon, everybody. Welcome to our third webinar of the year. Today we're going to talk about this afternoon. I think last time, and let me just introduce myself. Actually, my name is Tom Marsh. I'm joined today by Alexandra as well.
Hello.
She's sat next to me. We're going to share this webinar today. Last time I performed a webinar basically talking about a lot of the features around our Geology Designer. Today, again, we're going to talk about the Geology Designer, but we're going to introduce a new feature, and it's actually the uncertainty side of things. And we've talked a lot through different events that we have performed about introducing dynamic uncertainties, but we're actually incorporating a new feature for 18.2, which is associating basically static uncertainties only. I hope you enjoyed the webinar, and that's what our plan is today. Okay. So for those who have never sort of used or opened up tNavigator, and this is really the first interface that a user would see. And you can see here now we have an array of different modules covering subsurface all the way to basically to operations essentially. And so if I were to put this in terms of in more of a conceptual manner, tNavigator really began, and it's kind of our bread and butter. And it's definitely one of our most mature and definitely arguably one of the most powerful engines for simulation in the market so far. But it really began with our simulation engine, and through a lot of development aggressive development, we've actually branched out to a whole heap of different domains. And I've highlighted there the Geology Designer because not only is this what I'm focusing on today, and also going into the uncertainty side of things, it's really about integrating, basically building a static model that is suitable and also capable of feeding into our simulation engine. Okay. So in terms of Geology Designer, we have a variety of features that we've implemented, and so I have touched on these in my previous webinar, but essentially what we can cover is all the way from seismic and essentially generating input data through interpretations and well correlations, and then feeding that into our structural modeling processes and features that we have available in tNavigator. And then ultimately analyzing that data and then taking that through to the modeling world. So taking that through to fascist modeling, petrophysical modeling, and QCing those along the way. And then ultimately initializing those properties and perhaps taking that to our simulation, or furthermore, taking that into our uncertainty analysis. And to do this in a more integrated and seamless manner in actually one platform. Okay. So we talk about integrated workflows, and this actually in tNavigator here at Rockflow Dynamics is stuff that we are actually currently doing. And so whether that's actually building your static model from scratch, we are currently supporting and even consulting. We have some good examples where we are currently doing this. So whether that's just building your static model from scratch, so bringing your data in from perhaps another project, or just creating or bringing in raw information into the project, building your static model from scratch. So that's going from your well, seismic, structural modeling, property modeling, and then also essentially bringing that into the uncertainty domain. So capturing your static uncertainty on the way, running optimization, keeping your geological grid at the fine resolution the geologist wants, and ultimately taking that forward to simulation. So these are sort of three areas in the sort of static to dynamic world that we are currently supporting, consulting, and that we can do. But we can also, more importantly, integrate all of these in one field, one project. And again, we are currently doing with current clients, and we can offer to our clients as well. But the beauty about this is that Not only if we were to have some more information, if we were to get some more well data, or if we need to feed back into the static model, we can always tie this back into the static world and run automatic workflows to essentially update into our uncertainty analysis or simulation or whatever you're trying to achieve. Okay. So let's go into the Geology Designer. So I'm talking about the Geology Designer, and again, in my last webinar, and I've quoted the actual YouTube website, and because what I do is I talk about a lot of the features, a lot of the fundamental features that we have within the Geology Designer. So if it's something you want to know more about in more detail, please don't hesitate to contact me after the webinar. I can forward you the clip, and you can sort of peruse through that at your will. But what I'm getting at here is the fact that we have the tools, we have the capabilities to build a base case or first class static model to then feed into your uncertainty analysis or simulation, if that's the idea of your model build. And so there are various steps and various tools that we can do, and we have that enables you to do that. So we start here with the data preparation. So we load our data in, we do some seismic reconnaissance, perhaps some well correlation, some surface creation. And then once we've created our input data, we then go on and to build our static model, our structural framework. And we have various methods within tNavigator we can do that. So whether that's building a typical type of sugar cube style model, just using a simple grid type format, or incorporating more complexities like faults, so building a structured or unstructured type grid. And once we've built our foundations, then we can have properties to then interpolate through our grid. So that's going through to property modeling, upscaling our petrophysical parameters, so running fascies and petrophysical modeling on top of that, and then being able to QC that correctly. And then going on to volumetric calculation, and then be able to output these as some sort of property, table format, etc. So in essence, we can create a sound base case geological model at the resolution you need, and then perhaps take that to the next step, which is what Alexandra will talk about later on in the webinar, where we can take our base case workflow and essentially pick parameters that we want to take forward as variables or that we are pretty uncertain about, and generate multiple realizations of our base case model, making equal probable models, and how we can analyze that in our results for our results. Okay, so this is just really a slide going on the sort of concept of static uncertainty and how we adapt this inside tNavigator. So I talk about creating a base case model. So there's always a reason why geoscientists want to build a static model. And I have just put up here the classic volume calculation for STOIP. But essentially what we can do is build a base case static model, which we have the tools to do so inside tNavigator. And then what we can do is start to play around with some of these parameters. We get one volumetric, but obviously we can start to look at these parameters that we need for our volumetric calculation. So for an example, GRV, so our initial structural framework, our net to gross, our porosity, our saturations. And are we 100% certain that these are correct? And the answer probably is no. So what we do, we need to start to pick on various parameters within this perhaps equation and start to flex some of these parameters and build multiple realizations of our base case to build equal probable models and analyze those results accordingly. So things that might affect this, for an example, our structural or our GRV would be perhaps our contact. So flexing the contact, flexing maybe our structural surfaces, so top or bottom structure. And then we can move on to the distribution of our rock or our fluids. So we can start to play around with things like fascies and porosity and saturation. So what is the sort of workflow that we operate here with? So again, we start with our base case model. We then define our uncertainties and the ranges and the distributions of that. We generate some sort of sensitivity analysis and we run the simulation algorithm. And then as an output, we get a lot of different cases that are equal probable. And then we look at that, review that, we look at the results and see how we can sort of, I guess, analyze our outputs accordingly. So this is just really reiterating the point. So we start off with our base case, our hypothesis, one scenario. So for an example, we have one distinct seismic interpretation, one distinct geological concept, one distinct idea of what we think is there within the field that we're trying to model. And then we play around with it with our hypothesis. So we play around with some of the scenarios. So how do we do that? We play around with our horizon picks, play around with our contacts, and vary our contact. We vary some parameters perhaps within our facies modeling and petrophysical modeling, etc., etc. Okay. And we do this in a sort of very simple case in this sort of manner, where we start to play around with things like variogram analysis, the seed for our porosity, the azimuth perhaps for our trend maps that we're incorporating within our modeling, our contact. So what we do within the simulator, we generate distributions for each of our parameter that we want to incorporate. We then let the simulation pick a certain value from each of the distribution, and then we put that as a total. So whether it's a total volume or hydrocarbon ball volume or whatever, we put that in one distribution. And then we run this algorithm again. So the algorithm goes again and picks off a distribution, a point within each of the distributions, and makes a final result. And overall, we generate some sort of range or some sort of volume where we can analyze the uncertainty accordingly. Okay, so how do we do this in tNavigator? So just a last slide here, and this really shows one of the functions that we have within tNavigator, and it's obviously a powerful function. And here we have incorporated a workflow style engine. So here what we have in tNavigator, we have two operations: is record actions on user workflow, and also the operation just using workflows. If I was to click on user workflows, we have the capabilities of creating our own workflow that perhaps automates various processes and I guess, yeah, various processes that you want to perform within the project. But record actions on user workflow will essentially record all of the steps you took to build that geological model. And then if you wanted to input, if you had some new data and you wanted to input that new data within the model, you can regenerate the model automatically on the fly. But this workflow essentially becomes the engine or the driver or the foundation for the uncertainty analysis. Because what this allows us to do is to pick on various operations that or processes that we took to build the static model. And then what we can do is initiate some variables within a certain parameter. So whether that's our variogram or seed or distribution, etc. Okay, so what I'm going to do is now just dip into tNavigator and show you a quick introduction of how tNavigator or the Geology Designer looks, and then show you how we can sort of create a very, very simple and structural model and then take that forward to the uncertainty analysis. Yeah. Okay, so welcome to the Geology Designer. So this is the interface of our Geology Designer. And so what you see here is essentially on our left, we have a few tabs. And the main tab here is this geometry object. So any kind of information you bring into tNavigator, so any data you import into the project or you create inside the project will all be stored within this geometry object panel. So here I have my wells, my markers, logs, polygons, 2D maps, horizons, and even my model that I will be creating or have created. For each of my objects, I also have a settings page, so I can alter the various perhaps colors or size or or statistics of whatever object I'm visualizing within a particular window. So for an example, for my wells, I can toggle off my wells, I can show my wells, I can change the color, I can change the width of my well trajectories, etc., etc. And we have the settings for each of our objects we have inside our project. So then moving along the top, we have various windows that we have implemented within tNavigator, and this just allows you to obviously use the different windows to achieve whatever you're trying to do within the project. So for an example, we have a 3D window here. So I'm operating a 3D window, in this case, showing my 2 horizons, which I want to start creating my model with, including my wells. But we also have the option to have a 2D window. This shows the top-down view of my top structure. And so when I come to well correlation, I can start picking on wells to run my well correlation. And then interactively, that will then essentially update perhaps the well section view and start to where I can start to build various templates and initialize some wells that I want to start analyzing. We also have seismic. We also have a well table, which we can start to organize our data with. I can click on my markers, my logs, so I can start to control and see what data or information I have within my project, etc. Okay. So just move it on. I want to basically start off with the model build, because what I want to do is show you how we build a really quick, simple model, and then take that through to the uncertainty, because that's the real idea behind this webinar today. So let me just jump back into the original 3D window I had. And to build a simple model, what we have is this hammer tool. So this hammer tool is located on the left, and this is essentially my tool, which I always have open up pretty much when I'm working with the Geology Designer. Because what this allows me to do is run particular processes on particular objects I'm working with within my project. And you can see as I'm clicking on various objects, the calculations or the hammer tool is adapting accordingly. So to build a geological grid, what I need to do is come down to my 3D grids, and then I get various processes here on the left. Then so, because I'm just working with a one screen, I have to fill my page up a little bit. But what we have here is a variety of ways we can build a model within tNavigator. So like I was saying briefly in the introduction, we can build a simple sugar cube type model just using a top and base, which I will do today just for presentation purposes. We can also build a grid by points and faults. So we had some point sets, and any faults that you had within the project, they would get picked up, and you can sort of pick and choose which faults you want to use and build within your model, and which ones you want to make structured or unstructured. And if you had horizons and faults, we also have a process for that. So just going back to create a real simple grid, what I've done here is just introduce the top and base that I have visualized currently in my 3D window. This will give me one zone. I can also play around with the partitioning. So if I want to build my layering along the bottom or along the top or proportional, and then I can specify the amount of layers I want, and then I can give the sort of algorithm the choice of using conformable, discontinuous, erosional, and tell the algorithm how I want to what sort of horizon I'm bringing into the structural model build. So then also in one process or in one tab, I then have to define some sort of geometry definition. And so here, what I can do, I can detect this by using a typical boundary polygon, or I can pick a certain surface or map to help the algorithm guide the geometry build of my model. So once I'm happy with that, I can press apply, and what that will give me, it will give me if I was just to open up another window here, it will give me a blank or undefined property of my model build. Okay. And we have various ways we can QC this. We can come into the settings, and I can pick on my grid, my main grid. I can show the framework, so I can come in here, I can zoom in and actually see the framework of my model. I can use various IJK filters. Once I start picking or creating properties, I can create property filters. And what I have visualized here at the moment is a cross-section view. So if I was to click on my cross-section, like so, I can come up to my cross-sections. I can sort of float this down here if I wish. Ooh. Let me bring this up. Okay. And then I can start to filter through my grid accordingly, and just looking at perhaps the cell orientation, etc., etc. And obviously, when I've incorporated properties, so just for demonstration purposes, I have done. So this is, I think this is porosity. You can see the property distribution through a cross section as well. Okay, good. So once we've built a model, we then want to start to bring in our petrophysical data, so our well data. So here I've built a really simple well section window, and you can toggle. So at the start of my demonstration, I showed you can sort of click interactively on the well map and choose which wells you want to correlate across, or you can pick and choose here. You can like building your own well section template, and then what you can do is pick on the logs you want to bring into your project. Okay, and you can include things like tops, etc. And so once you've built a template and even done and completed all your well section correlation, etc., we then can utilize a process to bring that into the grid. So to do so, what we have here is a process called under my main grid called blocked wells. So again, using my hammer tool, I can come into blocked wells like so. I can create a blocked well, but for demonstration purposes, I've already created them. And I can click on a particular log, and then we have the particular averaging methods or your foundation averaging methods to bring those into your grid. So this is using the most of method for lithology, and you can treat log as points or as lines, etc., and press apply. And like so, we get these upscaled or blocked well logs where our wells are penetrating the grid. And we can do the same porosity, and even this is porosity, and we even have the option to perhaps bias your porosity to your Fashes analysis. And then obviously you would then want to QC that using a histogram window to see if it captured the heterogeneities, or even visualizing that in a perhaps well section window. So if I can come into my well section window like so, click on my blocked well logs, stick that interactively in a new well track, come into the settings, just showcase the color stick here, and I can come in here and I can see if I've captured the heterogeneity between my top and base horizon, which I'm incorporating in the grid. Okay. All right. Good. Okay, so once I've done that and I'm happy with that, if I just come back to my grid, I then want to interpolate that accordingly. So obviously I need to use some sort of interpolation method to then interpolate perhaps my Fashes and my porosities or whatever property you're trying to distribute within the grid. Okay, and then to do that, again, we come back to this hammer tool, which I'm using consistently. And then I can come into properties. And in properties, we have Fashes analysis and we have property interpolation. So in Fashes analysis, what we can do, we have various algorithms we can choose to help us distribute our Fashes. So that's here we've got Kriging and SGS are sort of the foundation, foundation algorithms which we choose. So for this example, we're using SGS. We pick on the blocked well log, and then for the sand, what we can do is incorporate trends, so like vertical proportion curves. I think here I'm using a map that I've created to help me distribute my sands. I'm going to take the fraction for my blocked well logs. I'm going to incorporate a variogram for my sands and an azimuth map for my sands. And then I'm going to press apply. I'm going to do the same for the shale and press apply. And then essentially what that would do, that would build me some sort of Fashes property, Fashes model. Okay. So something I've not touched on, and I will touch on really briefly, is our variogram modeling. So obviously we can create different variograms for different lithological features. So here I'm incorporating the sand and incorporating the shale. And what's actually unique about this, and I quite like this on a personal note, is I can build up a variogram analysis, specify the number of lags, number of intervals, etc. And it will build me a sort of pseudo map, which I can sort of interactively change. And you can see that my variogram points will adapt accordingly. And then I can fit a suitable range, suitable variogram for that particular feature that I'm trying to model. So in this case, it's sand. I do the same for shale. And then what I can do, come back into geometry objects, come back into the property, jump back into the facies analysis, and pick on the particular variogram I want to model. So for sand, variogram sand, for shale, for variogram shale, etc. Good. So then I can move on to perhaps my porosity. So for the porosity, I would do the same. I would essentially incorporate my porosity log. I perhaps condition to my facies. So where I have my high porosity values, I want them to be located in my sands. Pick on the variogram and press apply. And so once I pressed apply, I would then get some sort of facies porosity distribution. Good. So that's really, in a nutshell, really fast our property modeling. So then our final stage is creating volumetric calculation. So volumetric calculation again is activated through the gridding process. So what I need to do is come back to the hammer tool. Then I need to toggle on properties, and then come into auxiliary calculations. And in auxiliary calculations, we have a lot of different sort of, processes and features that we can operate on our 3D grid, not only to generate properties, but also to help us QC our grid as well, things like geometrical volume, etc. But to calculate volumetrics, we can utilize something called calculate volumetric properties. So in here, I would click on the grid I want, because obviously we can have multiple grids in our project, but I only have one in this particular one. And then we would use perhaps our porosity model, our net to gross model. We can utilize things like contacts as well. So if I had a contact, I could click on an oil contact and just use a drop down. And I haven't got a contact within this project, but I can basically utilize one in that feature there. And then for the rest of the process, I would just plug in some numbers. So for my saturation of water, oil, gas, etc., that I'm needed to calculate some sort of volumetric. And then what I can do is come across the output and output these as properties. So if I want a geometrical volume property, net volume property, pore volume property, etc., and obviously the final stoic volume property, I can sort of output these into my grid for me to look at. Okay. So once I do, I can press once I'm happy, I can press apply here, and then I can move on to my properties, and I can sort of locate these accordingly. So here I have stoic, so I can see the distribution of my stoic values across my grid. And then perhaps the final stage is that you want to look at these as numbers. So you want to see this in a table type format. And so to do that, what we can do is, again, we can open up the hammer tool. We can come across down here to tables. And then here I've already got a few tables I've already pre-created. But you can generate a brand new table by just clicking create table. And then you can specify what kind of property you want to output in your table. So here I've got hydrocarbon pore volume, but I can specify any of the volumes I have within my grid. I have stoic pore volume, and then here for the statistical type, I can output things like min, max, mean, the sum, the weighted mean, etc. And then at the bottom, what I can do is put in a discrete property. So if I have particular regions zones within my grid I only want to look at the volumetric for, then I have the ability to utilize discrete property there to filter on a particular area you want to analyze. So here I press apply and I press OK. And then what I can do is I can move across to tables and then click on a particular table I want to showcase. So here I've got two different tables that I've incorporated with our model. And here it actually just shows me my first class base case result that I've built relatively simply, but relatively fast for demonstration purposes, some sort of volumetric calculation. So what I want to do now is actually pass you over to Alex, who will take you forward of how we can start to play around with some of these features and start to analyze and input some parameters and talk about uncertainty analysis. So, Alex.
Great. Thank you very much, Tom, for this very good insight into Geology Designer. As always, if there's something that missing, you can ask questions and we can show you more. You all understand this is just because of the time limitation. We can show you more and many more features. But now I'm going to talk about the uncertainty, and I'm actually going to follow 4 questions. So I want to discuss questions such as why, what, how, and so what. So hopefully after we go through the first 3 questions, we will have the answer to so what already, but we can discuss that as well. So starting with why, I found a very nice quote that will probably represent it in the best way. So why are we doing the uncertainty analysis? And the quote is, I'd rather be vaguely right than precisely wrong. I quite like that, and I think that represents why we're actually thinking to look at our uncertainty analysis. In terms of what are we going to do, Tom already showed you briefly that we're interested in evaluating and estimating 2 different things. We want to look at the sensitivities of our parameters and how they affect our volumetric calculations, as well as we want to understand and quantify the uncertainty we have in our model. So what we're going to do and what people normally would like to do is to identify which parameters are uncertain, look at the distribution and ranges, and then run sensitivity and uncertainty. So now I'm going to go into how and show you how we do that in tNavigator. So again, Tom already mentioned that we have an option to use workflows. So if I go to the documents and open the workflows, we get this window that you saw already at Tom's slides. And here I already had one workflow that I prepared for this case. So the beauty of it is that at any point you can use your workflows that you created beforehand just by using the import button on the right. Or you create an absolutely new one, or you can also use an existing one and modify it. So there's an option to duplicate your current one. So I have just several processes that we're going to go through in my workflow. And before I actually describe them, I just tell you how easily you can modify or even start from scratch a new workflow. So depending where your mouse is, you would be able to bring a new process into a list of the different actions. So for example, if I stand here on my second process and I go and let's say I want to adjust one more variogram, right? And I want to edit here. So it's just for me not to get confused, I use the same one. So I click on the left-hand side. Now the green arrow is active. So by clicking on it, I'm moving and introducing a new process in the exact place where I want it in my workflow. If the place is wrong, because we want this list of the processes be in the correct order, in the sequential one, we can use these arrows to move the process up and down. So one down, one up, don't want this anymore, delete. So I delete this operation and I'm back to my original workflow that I want to show you today. So let's say that for the simplicity, we just look into some parameters and some uncertainties. So we will introduce the uncertainties in our variograms, and particularly we will consider our variogram azimuth as our uncertain parameter. So when you want to pick a parameter and create a variable, we go back to the input variables and you see we have the button that is add variable. So by clicking on this one, you are able to put the name of the variable you want. You can specify the type of the variable, put your base value, your mean, and your max. After you're happy with that, you press OK, and your variable appears here on the list. So I did this for my several variables in the variogram analysis, and that both azimuth and send and share variogram. And then I just picked two parameters in my facies interpretation and porosity interpretation. So in facies, you saw this window already. Tom described it very well. What are we doing and why? I took a random number as my seed. I take a seed number as my variable. And the same I did for the porosity. So in this simple example, we just have 4 variables, and we're going to look how they're going to affect our volumetric calculations. So obviously, after you define the variables, you want to see the impact. So therefore, we need to have the process of calculating our volumetric properties every time we have new sampling, every time we perform the sampling of our parameters. And it's absolutely the same as Tom just showed you. Source data and output, and then we finally create the table. So basically, we repeat very similar process. However, you don't need to use in this workflow any processes where you don't have uncertainties in this case. So we just pick only this ones and we go with this. The beauty of the integration in tNavigator is that you don't need to go from like close the project, open an additional module. We can just launch our uncertainty and sensitivity study from here, from our workflow. You can see there's a button that looks like a magic wand. So if I just click on that one, I'm able to create a history matching project. I hope that history matching project is not going to confuse you, because we're still going to look at the sensitivity and uncertainty. That's how we called our module, and for the shortening, we can't put all the processes that you can do in the module on as a one line. So therefore, it's create history matching project. Normally, we would go through what we used to do in tNav is to go through dynamic model and to add all the dynamic properties before we can start uncertainty analysis. And this is a very brand new, just this release option, where we can skip dynamic modeling and just use our table to calculate our volumetric uncertainties. So I select my table and I say OK. We need to save the project. That's OK, that's no problem. And we give a name to our new project. Call it test. Hopefully don't have other tests on this machine yet. Good, so it worked. You have a quick window where you can specify the core count of your machines. If you don't know about this, how tNav using cores, talk to us. We'll explain you happily more details about that. As soon as we're happy with that, we can move into a new window. In this new window, you can see that we have a selection of different algorithms available for you to do your sensitivity and uncertainty study. Every time I hover my mouse next to any of this algorithm, you can see a quick note just to remind you what is this algorithm about, how it does and performs the calculations, the sampling. And we also have more details in our user guide, specific user guide for the history matching uncertainty module. And it has very good description. And again, if you have more questions, don't hesitate to ask. So to start with, I would select a tornado one. The purpose of selecting a tornado one is because I would want to see as my output a tornado diagram to help me to analyze how my variables are affecting my, what's the correlation between my variables and the final results, the model function. So I pick on that, I say OK, and the calculations are started automatically. So every time I just open the calculations one, you can see we go back to the workflow, we run the workflow, and then we get the result. So I'll stop this project because I already calculated some results for you, and I just want to show and explain a bit more on the detail analysis instead of waiting. So stop experiment, and then I just jump to a different project. I call my history matching. So every time you perform a history matching, it's going to be tied to your project. And you can see the list of them if you've done multiple. So I did 2 ones. My first one, you can see this is Tornado. And just quickly go to the project window, and you can see this is the first experiment Tornado. I'll talk about this one first. So we go in the results, and what we can see what parameters were actually picked in our variables, what variables were picked as our parameters and values. And in the analysis, we have the Tornado diagram available. So you can see from here the correlation. So the longer the bar means the stronger is the correlation. The color of the bar will tell you about the negative or the positive correlation. And also which side the bar is heading, so is it right or left, will tell you also about the decreasing or increase, decrease or increase of the function value. So what I mean by function is basically our volumetrics on the top of the table and variables here on the left, right? So when we have the case like here, when our bars are not left or right, but looking at the same direction, it means that we have the same tendency for negative and positive correlation. So for example, let me pick the shale azimuth. We have the green bar, and means that when we increase the value of our azimuth, we get a bigger value for our function, for our pore volume. And the same for the send, but with the blue bar, when we decrease the send value, the azimuth of send value, then we also get increase in our pore volume. Okay, so normally in Tornado, when you specify that, you can also say which parameters have less impact on the function, on the final result. And based on that, especially if you have a very extensive list of the parameters, you can deselect ones that don't have much impact and then perform the more extensive uncertainty study with less number of parameters, but a more number of runs. So I did something similar. However, I didn't do really too many calculations, just to showcase what I did. I went and I created a new project. However, I just had 4 parameters and I decided to take them all in my next study. It was very quick to calculate them anyway. So I performed Latin hypercube sampling to represent the uncertainty. And again, when we go to the results with the Latin hypercube, we'll be able to see, let me just check it. Yep, we'll be able to see different results, such as Pareto chart, where, for example, you again can evaluate the significance or the impact of your variables on the final function. It actually looks like maybe it wasn't a bad idea to leave all this 4 together. They look like they have very similar impact. And then with this, you can use your model variables. You can use your results in our result table. And to analyze it a bit better, more representative way, you can use this button on the right-hand side and export table to a data file. And from here, you can look how this data look like in a histogram form, or you can also create and build your CDF and analyze your P10, P50, P90. So at the current stage, we are already building these features to be in our in tNav, and they're going to be very soon and in our next release, so approximately in 2-3 months. For now, we already have the values of P10, P50, P90 in sight. So let me go back, open the project, and just go again, and you see here are our quantiles. If you want to see more than just P10, P50, P90, you can add, not the parameter, you can add a quantile, any quantile you want. And the last step what I would show you today is how we actually can take any of these models and put them back in our Geology Designer project. So you can work with them more, you can compare, you can maybe change them. It's up to you. So for example, I would like to have a look at my P50 model. Let me show which actually model corresponds to this quantile. It shows me that it's model number 14. And I can take this and say, could you please put these variables back into my workflow? Done, and now go back to the project. So it tells me that the variables are replaced. I say OK, open my workflow quickly, and I can see that my base value now changed from the base one to the one that I took from the P50 model. So now just to finish this here, I need to run this workflow using this new base values. And after that, you can see that in your project, the volumetrics data would change, and we can even compare with the original one in the history and uncertainty project, and we can see that they're the same. Let me just show you quickly. So this is our totals. And then in the project, we go into this one. And obviously, when you have two screens, that is an easy one. But that's the line where we can compare. They are brought into the project from the uncertainty module. And last thing that I will show you before we move into the next part is that we have the option to create multiple cases. So I imported my P50 in my P90. Not good. So normally what I would do, I would duplicate this model, name it to whatever I want, so I don't overwrite an existing model with a new one. And let's say next time I would bring my P10. So I create a new one, it automatically becomes a current one, and then you can bring your new features without overwriting. And after that, you can switch between these models, compare them and analyze them, which is really, really good when you try to understand your data and understand your models even better. So on this, I probably stop for now. We have questions, and we also have the little information section at the end.
So thank you everybody so far for listening. What we're going to do now is just finalize everything with some questions. I believe there's a few questions online. But yeah, just as a final note here, we do have some events coming up within August and September, and these are pretty much training events and pub quizzes events. And the training events, I believe, is covering a lot of our new simulation side of things, and we are running lunch and learns for the geology or introductory to geology modeling for each of the locations. And these are free events to attend. I will be there for pretty much all of them, so I'll be happy to answer any questions or talk to anybody who is interested of coming to these events. So yeah, my email is listed there, and also Alex's email, so feel free to contact me directly. I'm happy to talk to you about the things we were talking about today. But yeah, let's see if we've got any questions online, just to finalize something.
So I think I'll start with a question. So there's one, I'll read it as it is. Hello there, tried to import workflow, but couldn't. I got a message saying failed to find region number declaration. So obviously, to be sure that we know what's the problem, we would ask you to share your project or at least a print screen on our email. So you can use my or Tom email or write to tNav.rdn.com. But I would do an assumption thing that maybe you don't have regions, because when we put in our workflow and we specified the regions, we had created the regions beforehand. So we had these regions before we started doing the workflow. So could you just check that your regions are there, and you put the number and you tick all the ticks. For more thorough investigation, please share the print screen of the error message, and also probably the model, so we can investigate it and tell you for sure.
Okay, so there's another question. During the table creation, is it possible to generate them based on filtered grids? So I'm assuming by filtered grids, you mean a particular property or something like that. So what you would probably do there is filter the grid. We have property filters available in the Geology Designer, and you can use the calculator statement to create some sort of discrete property based on particular, I guess, a particular range of values you want to filter on, and then you can input that into the table calculation and put that particular discrete property within the table creation, which would then output that particular result within the property that you've specified. Okay, so if that's what you mean, then we can. That's how we would do it. Otherwise, yeah, just fire an email to me and we can have a more of a discussion about that. That's fine. Anything else?
So there's one more question. I believe it's how are different structural realizations handled in the uncertainty workflow? So I believe that we can have a look. What do you have to start with? So if you have, for example, your seismic data, and you interpret your horizons from it, we actually have a slide here that will be just perfect to explain that. So just once again, right? In this example, let's say that you have you interpret it from your seismic data a horizon, your train horizon, but you have this uncertainty that you want to capture. So what we suggest is to introduce a variable that we just call Caesar. So the idea is that it ranges, it varies between -3 and +3 meters, just an example, and it means that we will lift or move down and move up our trend horizon on depending on which value of this variable will be picked. So as you can see here, we will get a new depth of our trend horizon, and the last step after that we will do, we will use a process that can help us to pull up the horizon to the markers, and then we will get as a result the updated horizon that is pulled up to the marker. So in this example, we have the trend, but however, if you have other horizons like the top and the bottom, you can do that. And the idea is because it's a workflow which picks automatically different values for your variable, you will be able to see different realizations. I hope that's what you were asking about in terms of structural uncertainty.
Okay, so what I think for the time being, what I will do is I'm going to take note on any other questions that have come through. There's a bit of an influx here. I've got some names here who have asked the questions, and what I will do is I will drop them a direct line to the answer of those particular questions. Some of them are quite specific. So I will be in contact, yeah, so what I would do is just from there, I would probably finish there. And so I guess thanks for listening from myself and Alex.
Yeah, thank you.
And hopefully we'll see some of you guys at some of our events. And feel free to come over and have a chat about any specific issues or fields that you currently are working with, or perhaps you want to work with tNavigator with. Okay?
Bring your questions, bring your models.
Okay, thank you.
Thank you.